Hello, thank you and welcome to my channel once again. So today we are going to solve this question. For the figure below, three resistors are connected in parallel as shown. Calculate I, the total resistance, II, supply current, III, voltage across the parallel branch, IV, current in the parallel resistor, V, voltage drop in the 5 ohm resistor, and then VI, the total power. Okay, so that is the circuit, and it's having three resistors. Okay, that is R1, R2, R3 connected in parallel, and the parallel circuit is connected in series to R4, which is what the 5 ohm resistance. Okay, and all is connected across a 30 volts supply. I hope you understand. All right, and we have to calculate for the total resistance, the supply current, voltage across the power branch, current in the power resistor, voltage drop in the 5 ohm resistor, and then the last one, that is the total power. I hope you are ready. Okay, so let's start with the solution. So first we are going to calculate for the total resistance. Okay, that is I. We are going to calculate for the total resistance. But before we calculate for the total resistance, let's first calculate for the power resistance, that is Rp. Okay, and we use the formula 1 over Rp equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is equal to what? 1 over Rp equals 1 over 2 plus 1 over 3 plus 1 over 4. So we are going to simplify the right hand side, okay, by adding 1 over 2 plus 1 over 3 plus 1 over 4. And we do that by finding the LCM, which is what? 12. So 2 goes into 12 6 times, okay? 6 multiplies 1 to be what? 6. Plus 3 goes into 12 4 times. So 4 multiplies 1 to be what? 4. Plus 4 goes into 12 3 times. 3 multiplies 1 to be what? 3. So this is equal to what? 13 over 12. So 1 over Rp is equal to what? 13 over 12. So we do cross multiplication, right? So Rp is equal to what? 12 over 13. 12 divided by 13. And this is equal to what? 0.9 ohms. So the power circuit or the power network, that is Rp, is equal to what? 0.9 ohms. So to calculate for the total resistance, that is RT, we add the power circuit, that is Rp, to the resistance R4, okay, to get our total resistance, okay. So this is equal to Rp plus R4, which is equal to what? 0.9 plus 5, and that is going to give us what? 5.9 ohms. So the total resistance, that is RT, is equal to what? 5.9 ohms. I hope you understand. So let's move on to II, and we have to calculate for what? The supply current. So IT is equal to what? Vt over RT. So Vt here is the total voltage, and then RT is what? The total resistance, and this is equal to what? 30 over 5.9. So when we divide, we are going to get what? 5.08 amps. So the total current is equal to what? 5.08 amps. I hope you are following the calculations. All right, so let's move on with III, and we have to calculate for the voltage across each resistance. Voltage across each resistance. So the supply voltage, that is the total voltage, is equal to what? VR4, that is the voltage across resistor R4, plus VRP, that is the voltage across the parallel network. So when you add the voltage across the power network to the voltage across resistor R4, you should get the total voltage or the supply voltage. I hope you understand. All right. So let's first calculate for VR4, that is the voltage across resistor R4. And this is equal to what? IT times R4. So IT here is the supply current. Okay. So we have 5.08 times 5. And this is equal to what? 25.4 volts. So the voltage across resistor R4 is for 25.4 volts. All right. So to calculate for the voltage across the power network, that is VRP, we are going to subtract the voltage across R4 from the supply voltage. Okay, that will give us the voltage across the power circuit. So VRP is equal to what? VT, which is the total voltage, minus PR4. And this is equal to 30 minus 25.4, which is equal to what? 4.6 volts. So the voltage across the power circuit is what? 4.6 volts. I hope you understand. All right. So since the voltage across the power network or the power circuit is 4.6, then VRP is equal to V1 is equal to V2 is equal to V3, and that is equal to what? 4.6 volts. So the voltage across R1 is what? 4.6 volts. The voltage across R2 is 4.6 volts, and the voltage across R3 is what? 4.6 volts. And then the voltage across R4 is what? 25.4 volts. I hope you understand. All right, so let's move on to IV, that is the current in the parallel resistor. All right, so I1, that is the current that is flowing through resistor R1. This is equal to what? VRP over R1. VRP is what? The voltage across the parallel circuit. Okay, so this is equal to what? 4.6 over 2, and that is going to be 2.3 amps. Then I2 is equal to what? VRP over R2, and that is also going to be what? 4.6 over 3, which is going to give us what? 1.53 amps. And then I3 is equal to VRP over R3, and that is 4.6 over 4, which is equal to 1.15 amps. So I1 is what? 2.3 amps, I2 is what? 1.53 amps, and then I3 is equal to what? 1.15 amps. I hope you are following the calculations. All right, so let's move on to V, and we have to calculate for the voltage drop in the 5 ohm resistor. So that is VR4, which we have already calculated for, and this is equal to 25.4 volts. So the voltage drop in the 5 ohm resistor, that is VR4, is what? 25.4 volts. So the last one, which is what? VI, we have to calculate for the total power. So total power PT is equal to what? IV. I is the supply current, V is what? The supply voltage or the total voltage. So this is equal to what? 5.08 times 30. So when you multiply, we are going to get what? 152.4 watts. So the total power PT is equal to what? 152.4 watts. I hope you understand. Please subscribe to the channel. Okay, subscribe to the channel and share the videos with your friends. Thank you.